Okay, hello. So now we're going to look at some questions in your kinetic particle theory notes. So let's first look at question number 9. All right, so the question asks, when water evaporates, so we are going from liquid, right, to a gaseous state, a gas state. Right, so what happened to the particles? Do they lose energy? Do they gain energy? Do they move around fixed positions, or they move closer together? Right, so we know that for liquid and gas, let's do the last option first. Liquids are closer together, closely packed, irregular arrangement, but gas is far apart. So definitely they do not move closer together. All right, and then moving about fixed positions, this is the movement of a solid. So this one also no. Right now, so now it's about whether it gains energy or it loses energy. So we know that gas has high energy, while liquid has low energy. So if I start from low energy and then I become high energy, do you think I gain energy or do I lose energy? So you're right. So I'm gaining energy. So over here, this is B. Right, next one. A test tube contains a liquid that is placed in a beaker of boiling water. So we know boiling water has a temperature of 100 degrees Celsius. Why? Because water has a boiling point of 100 degrees Celsius. So if it's boiling, it has to be 100 degrees Celsius. All right, the liquid X starts to boil immediately. All right, so what's the boiling point of liquid X? So the boiling point of liquid X has to be, it cannot be less than, it can be less than 0 degrees Celsius, right? However, it's liquid. So if it's less than 0 degrees Celsius, it will already be a gas. Because room temperature is 25 degrees Celsius, if the boiling point is less than 0 degrees Celsius, it will not be a liquid. It will be a gas, right? Now, the liquid cannot be exactly at 100 because if it's at 100 and I put it in a boiling water at 100, it wouldn't start boiling immediately. It will need to heat up and then it will start boiling. So it cannot be exactly 100 degrees Celsius. It also cannot be above 100 degrees Celsius because if it's above 100 degrees Celsius, the boiling point, right, it wouldn't boil because now the boiling water is only 100 degrees Celsius. So therefore, the liquid X boiling point has to be between room temperature as well as 100 degrees Celsius. So when you put it into boiling water, the boiling water is higher than liquid X boiling point. So this one has to be D. Okay, let's look at the next question. So we got 3 states of matter, solid, liquid, and gas, and we need to represent condensation. So condensation is changing from gas to liquid. So we are looking at this gas to liquid. So we're looking at this arrow over here. Right, now this is the one that we need to learn, very important. So this one maybe 3 stars. Okay, so using kinetic particle theory, describe the change in arrangement and movement of particles when condensation takes place. So how do I answer this question? Is that for condensation, it is from gas to liquid. So answering this question, the strategy is basically you describe the arrangement in gas and then you describe the arrangement in liquid. So this is what you need to remember. Arrangement in gas, then to arrangement in liquid. And then for movement, arrangement in gas, and then movement in liquid. So for example, you can say that particles change from far apart, random arrangement. So far apart random arrangement is basically the arrangement of particles in a gas. To closely packed random arrangement. Or you can use disorderly arrangement or irregular arrangement. So we have described the change of the arrangement from far apart random arrangement to closely packed random arrangement or closely packed disorderly arrangement. Now, for the movement, you will just talk about the movement of particles in the gas. So particles change from moving rapidly and randomly in all directions to sliding over one another, moving throughout the liquid. So over here we can see that we have the movement of the gas particles, and then we have the movement of the particles in the liquid, right? So this is the strategy of how to answer this question, right? The remembering of the description is really up to you. So hopefully you'll put in some effort to remember the description so that you can answer this question well, right? So I hope this has been helpful for you. I'll see you in the next video. Bye.